Okay, we were taking another integral. We've got the integral of x over 1 plus cosine x dx. Okay, the first thing I'm thinking about here is x with trig functions, they don't really work that well together, but what we could do on this is integration by parts. My only concern is integrating 1 over 1 plus cosine x is not going to be that simple, so I'm thinking before we do integration by parts, I want to try to clean this up some way. Now, one thing you could do on this is you could multiply by the conjugate, 1 minus cosine x, in the numerator and denominator. That's one way you could clean this up in order to get it ready to integrate. What I want to do instead is look at the half angle formula for a cosine. So we can look at cosine x over 2. And the reason I want to use this formula is because we already have our denominator. We've got our 1 plus cosine x right here. All we need to do is solve for it. You can get this value a couple different ways, but because we already have this formula, it's going to be pretty easy. So if we square this on both sides, we have cosine squared x over 2. And then for the plus and minus, you think even if you have minus 1 here, if you square it, that's just 1. So we don't have to worry about that part. Squaring the rest of it, we just get 1/2, 1 plus cosine x. Multiplying by 2, half's going to cancel here, and we're going to have 2 cosine squared x over 2 for our expression for 1 plus cosine x. So we'll take this and use it to rewrite our integral. Now first with this 2, I can bring this out front as a 1/2. Cosine squared x over 2 in the denominator, let's bring it into the numerator and write it as secant squared x over 2, and we still have this x dx. But now if we do integration by parts, now we have this set up because secant squared is going to be easy to integrate, x is going to be easy to differentiate. So we'll come over here and we'll do integration by parts using the DI method, just differentiating x and integrating this over here. First, differentiating x, derivative of x is just 1. Do it one more time and we get a 0. Integrate secant squared x over 2, that's just going to be tan x over 2, but because of the 1/2 here, we'll bring a 2 in front. Integrate one more time. Integral of tangent is going to be natural log absolute value secant x over 2. We'll bring another 2 out front, times this 2 is going to give me a 4 over here. So then we'll basically have our solution on the diagonals. The last row's got a 0, so we won't worry about that. That's going to wipe out any integral there. So writing everything down and distributing in our 1/2. Here, 1/2 times 2 is just going to be a 1. So we start with x tan x over 2. And then half times minus 4 is going to be a minus 2 natural log secant x over 2. Absolute value, add a plus c, and that's it. So it actually goes pretty quick that way. You may want to try to get this back to regular angles. You can use identities again to transform tan x over 2 and secant x over 2 back to the x angle. I'm just going to leave it. I think this is good enough as it is. So that's it for today. Thanks everyone for watching. Have a good day.